The next variable we're going to explore in weather is air pressure. So, what is the significance of horizontal and vertical variations in air pressure? And why is it something we want to know about? All right, let's define air pressure first. Air exerts a force. Believe it or not, you have a force pushing down on you from air. If you ever wanted to really think about it, see the wind moving, and the other week when you had some very, very strong wind go through, that air exerts a heck of a lot of force. Sometimes it blows over trees and damages power lines. But basically, air has weight, and it's a force that makes air have that weight. And it's mass, so the number of molecules times the acceleration. Acceleration very well might just be Earth's gravity. So, and Dalton's law is basically saying that each gas in a mixture of gases has a certain pressure. And when they're all combined, each of those pressures is the actual pressure of that mixture of gases. So, in other words, in the Earth's case, we have oxygen, we have nitrogen, we have carbon dioxide, we have water vapor. Each one of those exerts a certain pressure. When you put them all together, then you get what the actual pressure is. So, it depends on mass. And average sea level basically is 14.7 pounds per square inch. But it acts in every direction, so every building has it in it. So we don't collapse under it. You have it in you. Otherwise, we'd all be pretty small, probably. So, used to be a mercury barometer was what was used to calculate air pressure. Think about it. There was a vacuum in this little tube right here, and that vacuum, when you pushed the tube down into the mercury would be pushed up. I think the scientists were surprised when it happened at first, but they realized that that's what air does. Air has weight. It pushes it up. Basically a 1 meter column of mercury. We have several units for pressure, and the one meteorologists mostly use is millibars. But inches of mercury is very popular, especially in the United States, because of that mercury barometer you just saw there. And many people have home barometers that are in inches of mercury. That's why many meteorologists will use inches of mercury to describe it to you. Another thing about air, it's compressible. So, what does that mean? Well, you can push, literally with your hands, you can push air together to make it tighter. If you had or in a paper bag or whatever, you can push it. And so as you push it, there's more and more molecules in a smaller and smaller area, so you wind up with greater and greater pressure. Think about a tire. You can compress air into it to hold your tire up. So that means that at the bottom of the atmosphere, pressure will change faster in the vertical because air is all being pushed down on it and goes slower the further up in the atmosphere you get. So, rising air temperature can increase kinetic energy in a molecule. So if you heat air from the sun, the air is starting to shake more, that kinetic energy is going up like we talk about with temperature. Well, if the pressure has got, think about it. If you had everything in a closed container, there would be nowhere for that density to change, but the kinetic energy would be increasing, the pressure would be going up because the molecules are moving faster. However, air isn't in a container. So you get molecules moving faster. What do? They go start further and further apart. So you lose density, you lose air pressure. So in the Earth's atmosphere, when temperature rises, the air pressure gets lower. So think about it. In cold air, there's not as much kinetic energy around. It's denser. So the pressure is going to fall pretty quickly in the vertical relative to hot, humid air, where it's not falling as fast. Oh yeah, guess what? Humid air is less heavy than regular air. The more water vapor in the air, the lighter that air is, because the density of water vapor is lower than regular air. So, variations in air pressure. We have high converging winds pushing the air down, raising the air pressure up here, dropping the air down here, pushing it away. And the air pressure would increase, though, down here because we have winds coming down from the loft. So the ideal gas law basically says that pressure is related to density and temperature. If you know two of the three, you know the other. And then we have expansional cooling and compressional warming. So think about it. If an air parcel is rising up, it's expanding. As it's expanding, there's actually energy used. So it's actually being cooled. Now, if it's compressed together, there's an outside force working on it, pressure. So energy is being supplied to it. So it is warmed. So you have conservation of energy happening with this. So if you know that, you can actually calculate what the temperature is going to change like as it's going up in the vertical due to expansional cooling. And it actually changes at a rate of 9.8 degrees Celsius for 1,000 meters. So that's pretty quick. You think about it, if you go up 1,000 meters, a little bit over 3,000 feet upwards, you're dropping pretty significantly in temperature. 9.8 degrees is a pretty good drop of temperature there. However, moist adiabatic lapse rates are different. And they're different because heat is being released, latent heat. So that, let's just look at a few current weather maps. Well, pressure on the weather map here. Here's high pressure over this area of West Virginia here, Virginia. So air is being pushed down. Air weighs more. And it's colder right here than over here. So this is actually an area where the density is greater and the pressure is greater. Lower pressure over here. A lot of moisture coming in here too. So the pressure is going to be lower that way. You can actually look at pressure changes on this type of map. And I want to bring you down into West Virginia here a little bit. And it should come up here pretty quickly. There we go. And if you click on sea level pressure here, and that's what SLP stands for, take a look at Beckley right here. Current temperature is 56. Pressure is 30.26 inches of mercury. And that is reduced to sea level. If you click on it, I can get a 3-day graph of this pressure and temperature and wind. So here's temperature, here's dew points, and relative humidity going down, getting drier. And here's wind speeds, relatively light wind. But then you can look over here and see what's the pressure been doing. Sea level pressure of 1024 hasn't changed a whole lot. It's actually been going up slightly. So there must be high pressure coming in with time. So that is just one example of looking at pressure where you are. We can look at pressure aloft and see there's divergence occurring here over area of Kansas right now. And if we looked back at our weather map in Kansas, what do we find? The current weather map has low pressure there. So again, air is being pushed upwards and dropping. So this is just an example of what you're getting into with pressure this week. So I hope you find it interesting, and let me know if you have any questions.